Hello! In this video, I'm going to show you how to program the UnoProLogic. When you receive your UnoProLogic, notice it has two 8-pin, one 10-pin, and one 6-pin 0.1-inch single-row female headers. These headers are designed to accept the Arduino shields such as motor controller shield and Ethernet shields. The UnoProLogic comes with an FT2232H mini module. This module connects to the PC through its Mini B USB connector. The UnoProLogic has two push-button switches which are accessible by user code. It has four green LEDs at the back end of the board. These LEDs are accessible by user code. Also, note that the headers have tails that are long enough to plug into an Arduino board. There are three 8-bit 3.3 volt bus transceivers which are 5 volt tolerant. This allows the UnoProLogic to support the whole family of Arduino boards. So now let's connect the UnoProLogic to the PC and load up the drivers. Connect a USB Mini B cable to the FT2232H mini module. When the UnoProLogic is first connected to the PC attempts to locate a driver for the USB device. It won't be able to find the driver after several searches. The result is the device driver software was not successfully installed. So we will install the driver manually. Click on the Start button and locate the control panel. In the control panel, locate the Device Manager and click on it. When the Device Manager opens up, scroll down to the other devices on the left-hand side and right-click the EPT USB serial and JTAG cable. Select the Update Driver Software option. Next, select the Browse My Computer for the driver software option. In the next window, click on the Browse button and locate the EPT USB CPLD Development System CD. Open the Drivers folder and click on the EPT 2.0824 folder. Click OK to close the browse box, then click Next to start the Update Driver Software wizard. The wizard will start and a Windows security warning will be issued by the operating system. Click on the Install this driver the software anyways option. The wizard will continue to install the driver. It may take some time for the Windows OS to install all of the driver's files. When it's done, click Close. Under Device Manager, right-click on the next EPT USB serial and JTAG cable and repeat the same steps to install the driver. When the driver is loaded, check in the Device Manager to ensure that under the Universal Serial Bus controllers that the USB serial converter A and B are installed at the bottom. When these drivers are loaded, the operation is complete and the UnoProLogic is ready for use. To test out the drivers, let's run the EPT Transfer Test application. Locate the EPT USB CPLD Development System CD, select the Projects Active Host 64-bit folder, open the EPT Transfer Test Bind x64 Release folder and click on the EPT Transfer Test application. The application will load. In the drop-down box at the top, select the EPT USB serial and JTAG cable option, then click the Open button. Now the EPT Transfer Test can communicate directly with the UnoProLogic, so let's turn on the LEDs. Click on the 1 button in the LED controls block. Notice that the LED 1 light lights up in the UnoProLogic. Continue turning on the LEDs. Next, click the Reset button in the LED controls block. This will turn off the LEDs. Click on the blinky for a random pattern on the LEDs. To stop the blinky, click on the Close button. After that, click on the Open button. To send a collection of bytes to the UnoProLogic and have them sent back, you can do this by clicking on the Loopback button. Then in the multiple byte text box, enter some integers to send over. Make sure that they are less than 255. Click on the multiple byte button and the integers are sent to the UnoProLogic and immediately sent back to the PC and converted to hexadecimal bytes. You can do the same for the block loopback. Click on the block 8 button to send a predefined block of 8 bytes to the UnoProLogic. As soon as the block is received at the UnoProLogic, it sends the entire block back to the PC and is displayed on the block received text box. Click on the block 16 to send a 16 byte block. You can also enter your own set of integers in the block send window. The integers must be less than 255. This is because we only send bytes to the ProLogic. So click on the user block button to send and receive the block of bytes. So now that we have seen the UnoProLogic in action, let's get set up to program your own code into the CPLD. What we'll do next is to install the Quartus software and the Earth People Technology DLL. This will allow us to write, compile, and program user code into the CPLD. To get started, locate the EPT USB CPLD development CD. Go to the Quartus 12.1 SP1 folder and click on the 12.1 SP Quartus free windows.exe. Click the install button. Quartus installation will go through the process of unpacking all of its components onto your hard drive. This will take several minutes. There is a progress bar at the bottom of the window to show you how far along the unpack process is. When the Quartus is finished unpacking, we'll ask you to click on the license agreement and hit the next button a couple of times. This is okay, just take the default settings. Next, the software will start to install all of its components. Again, this will take several minutes, and you can monitor the progress bar to find out how far along it is. There's several components in there, so just wait for them all to install. Okay, once the software is finished installing, we'll need to add the EPT Blaster DLL. Locate the EPT USB CPLD Development System CD, click on the Drivers folder, then the EPT Blaster folder, open the x64 folder, and copy the JTAG HWMBFTDI blaster.dll. Bring up another Windows Explorer and open the Altera 12.1 SP1 Quartus bin 64 folder. And right-click to paste this DLL in this folder. Now the Quartus software is ready for us to use with the UnoProLogic. So let's go and create a project. We're going to use the data collector from the CD, and we're going to use the HDL project and an Arduino project. So bring up the Quartus 2 software, click on File, New Project, Wizard, click Next, and then click the Browse button, next folder. In the dialog box, browse over to Altera 12.1 SP1 Quartus Q Designs, create a new folder, title this folder EPT 570 AP U2 Top. Click the select folder, then type in EPT 570 AP U2 Top for the project name. Click Next. And at the Add Files window, click the Browse button and browse over to the EPT USB CPLD Development System CD. Locate the Projects HDL folder. Open the EPT Data Collector. Then open the SRC folder. Copy the following files: the Active Block VQM, Active Transfer VQM, Active Trigger VQM, Active Transfer Library VQM, EPT WireOr.v, and the EPT 570AP U2 Top.v file. Click the Open button. Click Next. Now select the family from the drop-down box, which is Max2. Then select the device from the Available Devices table, which is the EPM 570 T100C5. Click Next, and click the Finish button. Next, we'll import the pins. The UnoProLogic uses the same pinout for every project, so there's no need to select pins one by one. Just click on the Assignments, Import Assignments. Click on the Browse button at the dialog box. Locate the EPT USB CPLD Development System CD. Select Projects HDL. Then select the EPT Data Collector folder. Then select the EPT 570 AP U2 Top folder. Then locate the EPT 570 AP top.qsf file. Click Open. And next we're going to need to copy the constraint file over to the project directory. So bring up a Windows Explorer, locate the EPT USB CPLD Development System CD, select the Projects HDL folder, the EPT Data Collector, then click on the EPT 570AP U2 Top folder, locate the EPT 570AP U2 Top.sdc file, right-click Copy, then bring up another Windows Explorer and browse over to our project, right-click Paste File, and now we're ready to compile. So first let's check and make sure the pins selections are okay. Click on Assignments Pin Planner. And here you can see the pin assignments are all loaded, ready for compilation. Look in the location column. You'll see all the pins are correctly set. You can verify this against the schematic. So hit the Compile button at the top, and the Quartus software will compile and produce a programming file. In the system window at the bottom, you'll see messages about the compilation and synthesis. Once this process is done, you'll see the full compilation was successful window. Just click OK. Next, we're going to click on the Program button. When we do that, the Programmer window will come up. If you notice, there's no hardware selected. So we're going to click on the Hardware Setup button. If the UnoProLogic is connected to the PC and the USB driver is loaded, you will see the EPT Blaster version 1.3b in the Available Hardware Items box. Double-click on the EPT Blaster. Notice that the currently selected hardware indicates that the EPT Blaster is selected. Click Close and make sure the Program Configure checkbox is selected, and click the Start button. The programmer will begin programming the CPLD. You can check the progress bar to see how far along the programming is. Once programming is complete, the UnoProLogic is ready to use with the Arduino hardware. With the UnoProLogic programmed, we will now connect it to the Arduino Uno, program the Uno, and run the C# application. The Data Collector project is a simple data transfer application between the Arduino, the UnoProLogic, and the C# application running on the PC. The C# application sends a start-stop command to the Arduino. The Arduino in turn sends a series of random bytes back to the C# application through the UnoProLogic. The data transfer is made possible by the UnoProLogic, and the data can be transferred up to 4 megabytes per second. So let's connect the Arduino to the PC, plug in the USB cable. Now you should have already loaded the drivers for the Arduino so that it will connect with the PC and select an open COM port. After this, it is ready for the Arduino IDE. Bring up the Arduino IDE, go to File, Open, locate the EPT Development System CD, browse to Projects, Arduino Data Collector code, open the folder, locate the Arduino Data Collector code u2.ino file, select it, click Open. Then when the file is ready to go, click on the Upload button, and the code will be loaded into the Arduino flash. The Arduino will finish loading. Next, we will connect the Arduino to the UnoProLogic. So disconnect the USB cable, angle the Arduino and the UnoProLogic so that the one side of the header tails lines up with one side of the Arduino connectors. Then line up the other side tails to connectors. Gently push the connectors together. When they are connected together and everything's tight, plug in both USB cables. Next, we will bring up the Windows Explorer, locate the EPT Development System CD, browse to Projects, ActiveHost 64-bit, open the EPT Data Collector, bin, x64 release folder, locate the EPT Data Collector.exe file, and double-click it. When the Data Collector window comes up, find the drop-down box at the top, click on it and select the EPT serial and JTAG cable, then click Open button. Next, click the Start button, and the C# application sends the start signal to the Arduino. The Arduino is in its loop, but does not send any data back to the UnoProLogic until that start-stop signal goes high. When it does, it calculates a random byte, puts the byte on the data bus lines to the UnoProLogic, and asserts the write enable signal. The UnoProLogic's code is sitting there waiting for the write enable signal to assert. When it does assert, it reads the byte on its data bus lines and sends it to the C# application over the USB. The C# application receives the byte and displays it in a text box. This system repeats this process until the stop button is pressed. So, that is it for the Data Collector project. Before we go, I want to walk you through one of the more useful aspects of the USB CPLD development system. Let's add an LED heartbeat to the project. Adding code, compiling, programming, and running is all done without having to pull cables or switch software. This makes development really fast and really easy. So let's stop the data collector. Then I will bring up my code editor. Now, I like to use Notepad++, but you can easily use the Quartus software editor. So what we're going to do first is to add a timer to control when the LEDs get updated. For this, I need to add a parameter, and we'll go to the top, and we're going to hold my my max count value. So I'm going to call this LED count. This will be a 32-bit value, but I'm going to limit it to 2 to the 24th. This will take 6 Fs. Next, I need to add a 3-bit vector called LED reg to hold my shifted LED value. Next, I need to add a timer vector called LED timer. This is going to be a 32-bit value that will increment. Next, add the ternary statements so that if a bit value of LED reg goes high, the corresponding LED will go low. This will, of course, light up the LED. Else, let the value float, which will turn off the LED. And we'll do this for all 3 LEDs that we have access to. Next, add a synchronous block, and I'm going to give this a title. Okay, add an always statement using the clock edge and reset, so that when reset happens, the LED reg will equal 1. This will give us one high bit to continually shift to the right. Next, set the LED timer to 0. Then in the synchronous part of the block, if LED timer is less than the max count, count by 1 per clock. Else, shift the one high bit to the right by 1 bit and set the other 2 bits equal to the other 2 bits. Set the LED timer to 0. This will cause LEDs to continually shift to the LED one to the right. Okay, so once we are done with the code, go back to Quartus and simply hit the compile button. Wait for compilation to finish, then bring up the programmer. Once the compilation is finished, then bring up the programmer and hit the start button. So as soon as the programmer is done, the CPLD starts executing the new code. It's as simple as that. So there's the LED heartbeat. It continually shifts one of the LEDs to the right with a delay between each update of the LEDs. Okay, so let's try something a little bit different. Let's change the LED max timer value to make the shift a little bit faster. This is pretty easy. We'll just go back to find that parameter, the Notepad++, find the LED count, set the value now to 7F, FFFF. I'll go back to Quartus, hit the compile button, hit the programmer button, and hit start. CPLD gets programmed. As soon as it's done, our shift's a little bit faster. So, that's it for an introduction to programmable logic using the UnoProLogic and using the Quartus as the development environment system. This is a very simple, quick way to do things. It is up to you to create a more useful project that can transfer data to and from the Arduino or any other digital device for that. All of the code for the Arduino, UnoProLogic, and C# application are in the user manual. Thanks for watching and happy coding.